Welcome to Think Constructive. I am Isha. This session I have designed for CBSE Board, Class 10th students, subject Artificial Intelligence, chapter Natural Language Processing, and this is the third session of Natural Language Processing. All right. So I'll just show you quickly what all we will be covering in this session. So here is the list of topic which I will be talking about in today's session. So mainly I'm starting with data processing of natural language processing. All right. So this is the first part for data processing because data processing in itself is a big topic. All right. So I have divided data processing into two parts. In this session, I will be covering the first part of data processing of natural language processing chapter. And here is a list of topics. I'll give you the overview of data processing, followed by steps involved for data processing. Then I will discuss corpus, followed by text normalization, and I'll be covering all steps of text normalization in this session. Okay, so let us start with data processing overview. Can you think of what is data processing? It's hidden in its name itself, processing of data. All right. But for what? We are reading data processing in context of natural language processing. That means processing of data which will make natural language easier. And for what? For machines or for computers. Right? In my previous sessions, I have already talked about computers understand human language, but not as we talk or we communicate with each other. Rather, that language has to be converted into numbers because actually computers understand only the language of numbers. So how will we feed that data, or how the something can be done for the computer so that computer can really understand human language? All right, we have seen a lot of examples, application areas, and everywhere the computers are understanding human language and making everyone's life very easy. But in order to reach to that level, there are certain algorithms, certain softwares which are running behind the scenes and which are actually making it possible. So in order to reach there, the natural language or the human language shall be converted into numbers, right? And that's what is data processing. All right. So now if I read out this definition, that will make a lot of sense for all of us. All right. So what now this definition is saying? Data processing helps to process and convert natural language to what? To computer understandable format, that is numbers. And this conversion now involves few steps. All right. So in order to do this conversion, there are certain steps involved. Okay. So now we'll talk about those steps. So here are the steps which are involved in processing the data. Number 1, text normalization. Number 2, bag of words. And number 3, TF-IDF, in short everyone says. So it is term frequency and inverse document frequency. All right. So these are the steps which are involved in data processing. So we will be mainly focusing upon this step today, that is text normalization. All right. So before text normalization, let us have a look at the corpus. So corpus is not the step of data processing, rather it is an important term which will be used throughout in the data processing steps. So that is where we'll talk about corpus. Just before starting with the corpus discussion, I would like to tell you, if you have not yet already seen the first and second part of this session, please go ahead and see that. That will give you a more, clear and better picture about the topic and about the chapter. So I have already given the links in my description box for that session 1 and session 2. So if you haven't gone through, please, I would suggest go through that. That will be very helpful for you. Okay. Yeah. So now let us start with the corpus. So corpus, I'll first read out the definition so that you get a clear understanding, and then I'll give you some example. Okay. So what corpus means is, corpus can be defined as a collection of text documents. It can be thought of as a bunch of text files in directory, often alongside many other directories of text files. What does that mean? It is a collection of text document. That means a lot of textual data, document 1, document 2, document 3, and so on. It can be n number of documents. And each of these documents are what? Text documents. See? Okay. So, these text documents collection is called as corpus. Alright, it can be residing in one directory. Okay. It can reside in one directory, the collection of bunch of text files or text documents, and that is known as corpus. Where we will be using corpus, I'll let you know in a while. Okay. So I hope it is clear what is this. So now I will just take one example. So my example says this. This is a corpus. What is this? We can use health chatbots for treating stress. We can use NLP to create chatbot, and we will be making health chatbot now. Health chatbots cannot replace human counselors now. So this is just one paragraph you can see. Okay, so this is one example of corpus. And what we'll be doing next with this. So basically, in data processing, we get bunch of documents, rather bunch of textual documents or textual files. We take that and we try to convert that into numbers. So in simple terms, I can say for any data processing, starting corpus acts as an input. Okay, so a corpus, a collection of documents is taken, and that will be used to do certain processing steps to reach to a level where it is converted to numbers, and then computer will actually start understanding that. That is how we train our machines to learn human languages. All right, so this is just a human language, right? We all understand. But now what we'll try to achieve, we'll try our computer, our machine to understand this human language. All right, so this is taken as an input for the data processing next steps. All right, so let us move from here. So here is the actual core first step of data processing, which is text normalization. All right, so as I have written here, text normalization is the first step for converting human language to numbers. Okay, so it's the first step, right? Now, what does it do? It helps in cleaning up the textual data in such a way that it comes down to a level where the complexity is lower than the actual data, right? So cleaning up the textual data is very, very important point. And then complexity is lower than the actual data. So actual data we have just now seen. I'll just go back. This is my actual data, this thing. And text normalization, what it will try to do? It will try to convert it into some more simpler form, because it's complex, right? It's a group of sentences, some punctuations, some words, different formats of words, all those things are captured here. Okay, so what text normalization will do, we'll take this data and we'll try to convert into the lower complexity of data. All right. So it will clean it up and try to convert into the lower complexity. We'll see it how and what all we need to do to reach that lower complex format of the data. Okay. So what are the implementation steps? So I said text normalization converts data, actual data, to the lower complexity. But how? So here is how. So these are the steps involved in order to convert the data to the lower complexity of data. Okay. So it's not like just one step or two step. Here are the multiple steps which will be used to convert the data into the lesser or lower complexity of data. So step number 1, sentence segmentation. So we have seen a paragraph. Okay. So that will be first go through with the step as sentence segmentation. So actually I will write here from the corpus thing is reached to sentence segmentation. After sentence segmentation, it will go to tokenization. After tokenization, it will go to removing stopwords, special characters and numbers. Then once this step is achieved, it will reach to another step, converting text to a common case. All right. And then once this step is done, once it is reached to this step 4, that is converting text to a common case, it will either reach to stemming or lemmatization, not both. All right. I will tell you what it is and why both are not needed. Okay. So this is how it will go. First step 1 has to be executed, then only you'll reach to step 2, then only output of a step 2 will act as input of a step 3, output of a step 3 will act as input of a step 4. That's how it will flow. Okay, it's all interlinked. Okay, so these many steps we'll be covering in this session. All right, so we'll move from here. So the first step of text normalization is sentence segmentation. This is what we have seen as written. So the second point here is the whole corpus is divided into sentences. So the corpus I have shown you, remember this example. This is a complete paragraph. Okay. So this has to be broken down into sentences. This is what it meant. And then so this is the first step we covered. The first step we covered, then the whole corpus divided into sentences. I hope all of you understand it now. And then the next point is each sentence is taken as a different data. So now the whole corpus gets reduced to sentences. So ultimately the idea is reduce or break the corpus into separate sentences. Okay. So how? See, this was the corpus which we have taken as an example, and we have got 3 sentences out of it. So how? We can use health chatbots for treating stress. That is sentence number 1. Okay. We can use NLP to create chatbots, and we will be making health chatbots now. That is my sentence number 2. And then health chatbots cannot replace human counselors now. That is my sentence number 3. So by doing this, we have achieved, or we have got the output of sentence segmentation. So this was my input and this was my output. All right. So now this output will become input of my next step. Remember what was that? That was tokenization. Okay. So before getting into that example, we'll just understand a couple of terms here which will be used in my tokenization steps and afterwards also. Okay. So these terms are very important to understand. So first term is token. So token is a term used for any word, number or a special character occurring in the sentence. Okay. What is token? Any word, number or special character. So whatever different words, numbers, characters are appearing in my sentence, all those are termed as token. All right. Sorry. Then what is tokenization? Okay, that's this course step. So tokenization. So that is the main step. All right. So what is done in tokenization? After sentence segmentation, each sentence is divided into tokens. What are tokens? We have already understood. Okay. So under tokenization, every word, number and special character is considered separately. Okay. Notice here, separately. And each of them is now a separate token. Okay. Understood? And then token list. So token list, collection of tokens. We must, after tokenization, we have retrieved or we have got a whole list of or whole bunch of tokens. All right. The collection of tokens which are retrieved from the tokenization is called token list. All right. So I hope now the three terms are clear and the core step, which is tokenization, is also clear. So now we'll have a look at the example. So this we have got after sentence segmentation. So this is now acting as an input for tokenization and output of the step tokenization. Okay. So sentence segmentation, we have got all separate sentences like this. And now those sentences are divided into tokens. So what tokens we have got from first sentence? What all can be the tokens? We can use health chatbots for treating stress, full stop. All right. How many tokens? 3, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, all these are separate tokens. Okay. Similarly, for second sentence, we have got tokens, and for third sentence. So I hope tokenization is very clear now. All right. So from here, we'll move to the next step, which is removing stopwords, special characters and numbers. Okay. So we have got a whole lot of separate tokens or the list of tokens. Okay. From that, now the next step is to remove certain things which are unwanted or extra and which doesn't add any significant value for the computers to understand the natural language or to process them. All right. So whatever is the unwanted or extra kind of stuffs, those will be removed in this particular step. Okay. So before that, we need to understand what is this term stop word means. So stop words are the words which occur very frequently in the corpus but do not add any value to it. They comes a lot. We'll see a lot of word in the corpus, but they are not actually doing any particular value addition to understand the context or meaning of the corpus. Those are called stopwords. For example, it can be any helping verbs, all right, or any connecting words. Those kind of words are, they keep occurring, but any specific value they are not adding. So the idea is to remove them from the list of tokens. Okay. So for example, can, for, to, not, now, and, will be. So certain things I have covered. There can be more. All right. So now, and other than that, there are certain special characters. So some special characters I have written here. There can be many more. So those special characters in general, they do not add any value. They are just connecting two words, or ending some statement. Those kind of words are there, but not any significant addition they are doing. So they will be removed. And then the numbers. Okay, numbers we all know. Okay. So I'll come back to I'll come to some exception also, but for now, just remember this. And now with this, we'll see the example. So this box is the output of what? Tokenization, right? So now this will become input and this will become output. All right. So output of tokenization will act in this step as input. And what is that? If you remember, we got these tokens, which all are listed here. All right. So after removing stopwords and a special character, what output we get? We, use, health, chatbot. See, this can in this step is removed. Okay. This for, see, can we see for here? No. So for is removed. All right. So that's how we reach to these many number of tokens. Okay. After removing stopword, special characters and numbers. Okay. Clear? We move from this slide. So what is it doing? I mean, when we remove stopwords or special character or numbers, why are we doing that? As we discussed, any unwanted thing, any unwanted token, we remove so that computer can actually focus on what is really important, really meaningful. All right. So this will help in that way. That means to give more valuable tokens to the computer, we perform this step. Okay. And then another thing is, depending on the nature of the corpus, a decision can be taken to remove or keep certain special characters. So point here is, there is no blind rule that whatever special character or number is coming in the corpus, I just go ahead and blindly remove that. No, we don't do that. What we do is, we see the nature of the corpus and the significance of that particular special character or number in the corpus. If it is really adding the value to that, we don't remove them. Otherwise, the whole corpus will become meaningless. Okay? Because ultimately, idea is to reach to the meaningful term. And if by removing something, in particular case, it makes that corpus meaningless, then we don't remove that. Right? So, that's what I have captured a note here. In case corpus contains email IDs, then special characters and numbers becomes important, right? Isn't it? You might be having some email IDs in which probably you must have taken some particular numbers, some particular dates in your user ID. So if you will remove that, then in that corpus, that email ID itself gets changed. So it doesn't serve the purpose. It will rather be confusing. So in that case, we will not remove it. For example, let's say some user ABC. Okay. ABC has taken some important date as let's say 80, let's say 80, 81, some fictitious number, fictitious ID I'm taking at gmail.com. This is only for demonstration purpose. I am not taking any real or anyone's user ID. Okay, so in this you can say some numbers are coming, but those are part of email ID. We just can't do away with that. We cannot remove it. Okay, and similarly goes to this @ character or this dot character. These are special characters. Ideally, according to this step, those should be removed. But no, this step also says only those special characters or numbers should be removed which does not make any sense to the corpus. Okay, or rather which does not add much value to the corpus. But in this case, these two are very important as special characters. So we will remove that, the entire meaning of the corpus gets changed and it will be confusing. So we will not remove it. So I hope this is clear, right? We'll move from here. So this takes us to the next step, converting text to a common case. So that is another step. That is my step number 4. So what we have done, we have converted corpus to sentences, sentences to list of tokens, and from list of tokens to removing any stop words, special characters or numbers which are not adding any value to the corpus. Now from there we move to the next step, which is converting text to a common case. I have just taken the example of one word here. All right, you can pick up any word and try all these things. So again, the rule remains same. The output of the previous step will become input here and I get some out. Okay, got it? So for example, what happens is any word in the computer's language, if it is written in different cases, computer treats that differently. Okay, so in computer's language, if I put this hello, this is one word, this hello is separate word, this is another word, this is another, likewise this. So how many words I have written here? 7. So these all are 7 separate words for computer. Okay, got it? So but we all know hello is one word, and according to my this in this processing steps, I want this hello should be treated as one word, no matter in whichever case I have written it. Okay, so for making those things very clear to computer, all the tokens are converted to similar case. All right, and always it is preferable to do it in lowercase. Okay, so whatever tokens you are getting, those should be converted to lowercase. So in this example, in 7 ways we have written hello, but the word is actually hello. So after converting to common case, I'll get only one word, that is hello, all in small letters. Okay, so computer will now understand this as one word rather than understanding the one hello word as 7 different words. Okay, so clear that confusion by converting all the tokens to lowercase tokens. Okay, so now we have converted our tokens to lowercase tokens. What next for us? Remember, this is taking us to the next step of data processing, which is stemming. If you remember, I showed you there are 2 processes after converting tokens to a lowercase. There are 2 processes, stemming and lemmatisation. One would either go with stemming or with lemmatisation, not both in together. Okay, I will either use stemming for normalizing my data, or I will use lemmatization for normalizing my data. Not both of them. Okay, because both are similar kind of process. I'll tell you in a while what differences do they have and when to use which one. Okay, but before everything, let us understand what is it. Okay, so stemming. So what do we understand from stemming process? Words are reduced to their root words. What do we mean by root words? Let's say I have taken a word making. Okay, so I've taken a word making, but is it a base form of the word? The original word is making? No, correct? What is the original word? Original word is make. Okay, so the example what I am taking is making, but this is not the root form. The root form is make, isn't it? The root form is make. So whatever words we are getting in our corpus, we will be converting them to the root words. Okay. So then this takes us to the process understanding. What is the process? Stemming is a process in which affixes of the words are removed and the words are converted to their base form. That's what we talked about, the root word, the base form. So for making, the root word is make. The base form is make. All right. So whatever extra things are added in the word or any conversions are done in the word, everything should be removed and the word should bring back to its base form. This is done as a part of process called stemming. Okay. And once the stemming is done, the word which we get as an output of that is called stem. Okay. So what is the stem? Stem is a word which we get after affix removal. All right. Understood? Okay. So we'll move from here. Where are we reaching? We are reaching to certain examples of stemming. Okay. So I have demonstrated certain examples. I hope the process and what do we understand from a stem, it's clear. So now we are reaching to certain examples. Let's say healed. What is the affix? Ed. Okay. And let me just change it. Color. Yeah. So what do we get? After affix removal, the word heal. This is the stem. Okay. So this healed word is the stem. Let's say if I have the word in my corpus as healing. So what is my affix? Ing. And what do we get after affix removal? Heal. But because heal is the base form of the word or the root form of the word. All right. Similarly, healer, we are getting heal. Studies, the catch here. What is my affix? Es. What are we getting after stemming? Or what stem we are getting here? STUDI, study. Because what it has done, it has just removed ES, which is the affix. Okay, I'll come back to this point. Studying. Remove ing, getting study. STUDYING. Removed ing, STUDY we are getting study. Root word, base form, good, right? Move from here. Making. Remove ing, getting make. Perfect. All right. Made. Can't see any affix, right? What are we getting out of it? Made. Is made a base form? In general, there is no base word called as made. All right. I'll come back to it. Then caring. Remove ing. I am getting car. But wherever in the corpus caring word is used, in the context of that caring, if I am getting car, does it make any sense in that context? No, right? So how many catches I am getting here? 1, 2, 3. 3 words I am getting here which are not meaningful in respect to context, or actually there is no word which is existing, or that is not the base form of the word. Okay, keep that in mind. I'll come back to this point. For now, I'm moving from here to lemmatization. Okay. So as I said, I will either use stemming or lemmatization, not both, because both does the same job. When I say same job, see the first line, the same line I have written here, which I have given you in the stemming. Words are reduced to their root words. Stemming also does the same thing. Okay. So then, what is the process in lemmatization? Lemmatization is a process in which affixes of the words are removed and words are converted to the base form. Again, same definition. Okay. Then, what is the difference? See, in lemmatization process, once this is completed, we get a word out of it converted to their root or base form, right? Base form or root form. Okay. What are we getting after as an output of lemmatization? Lemma. In stemming, what we were getting? Stem. In lemmatization, what are we getting? Lemma. What is lemma? Lemma is a meaningful word which we get after affix removal. Okay. Lemma is a meaningful word which we get after affix removal. So meaningful word is very important here. In a stem, we were not talking about meaningful word. We were talking about only getting the base word or root word, that's it. But lemma is a meaningful word. So what is the difference? Stemming not necessarily gives you the meaningful word, but lemmatization gives you the meaningful word. Okay, so now we'll go back to the similar kind of examples. But in terms of lemma, what are we getting here? We'll notice. Okay, so healed. Same. Affix ed, lemma heal. Stem and lemma remains same. Healing. Ing removed, heal. Same. Okay. Healer. Er removed. What are we getting? Heal. Same. No problem. Studies. Affix removed, es. What am I getting? study, study, not studi, which we were getting in stemming. Okay. So this is a good meaningful word for me. Studying, ing removed, study, no problem. Making, ing removed, getting make, no issues. Made, no affix. Am I getting made out of it, which was a stem? No, I am getting make, which is actually the root or base word. All right, good. Caring, ing removed, I am getting care, C-A-R-E, care, not car. Because car itself is a word, but wherever caring is used, if you will put car, doesn't make any sense, right? But if you will put care, it makes sense. Okay, so I'm getting a good word here, care, a meaningful word here, care. So now you have got two are similar processes, stemming and lemmatization. But lemmatization gives you the more meaningful word as an output. Okay, so lemmas are the meaningful word, whereas stems are not necessarily the meaningful words. Okay, understood? So I hope by this time the process and their differences are very clear. So I'll just show you the differences also for stemming and lemmatization. So I hope you have been following all those things, and you must be having in your mind whatever I have discussed. I'll just read out these things just to reiterate, reinforce the steps. Okay. So the first difference is stemming is a process in which the affixes of words are removed and words are converted to their base form. Lemmatization is a process in which affixes are removed and words are converted to their base form. Same. Second, word which we get after affix removal is called stem. Whereas in lemmatization, the word which we get after affix removal is lemma. Okay. Third point, stem is not necessarily a meaningful word, whereas lemma is always a meaningful word. Same points? Okay. But now the catch here is, when we say the stemming doesn't give me meaningful word, that means it just takes words, remove their affixes and gives me the output quick, right? Because it is not doing any extra processing. It is just removing the affixes and giving me the output. So its processing time will be faster. So that is where it is saying shorter execution time, because no extra steps are involved. Whereas when I talk about lemmatization, longer execution time. Why? Because it is doing one extra step, isn't it? It is removing the affixes, same as the stemming. But in addition to this, it is also ensuring that after affix removal, the word which it is giving us as an output is a meaningful word. That means in order to ensure that word is meaningful in every sense, it is doing something extra, some extra processing, some extra steps. That means extra execution time. That is where longer execution time is written. All right. And then I have given you some examples, like we have seen 3 different cases there. So studies gets converted to study, caring gets converted to car. But whereas in lemmatization, studies will get converted to study, STUDY, and caring gets converted to care, not car. All right. So I hope stemming and lemmatization differences are very clear to all of you now with all the examples. All right. So just to summarize what all we have covered in this session, we started with overview of data processing, followed by corpus, and then followed by text normalization, overview, and all the steps of text normalization. All right. So I hope with all these explanation and examples, text normalization looks very simple, isn't it? It's very easy. And just one more point to mention here. There is if you are comfortable with Python, there is one very interesting library in Python named as NLTK. NLTK. Natural Language Toolkit. And this library will give you all the methods or libraries which will be used to do the text normalization steps. So by just using the methods, different methods of this library, you can develop the code for text normalization. And you can, put in any corpus and generates the outputs. Okay. So if you have time, explore this, learn this, and do all this magic by yourself. All right. So isn't it very easy? Right. So just think about more and more examples, and this will give you more clear picture. So with this, I will conclude today's session. So in the next session, I will be talking about the second part of data processing, which will include the discussion of TF, IDF, and bag of words algorithm. So these 2 topics necessarily I will be covering in my next session, and with that I will be concluding the chapter Natural Language Processing. All right. So stay updated with the next session and click the notification bell so that you are always get notified. Subscribe to my channel, and if you like the session, hit a like button, share with your friends and more people so that everyone will get benefit out of this session. Okay, all right. So, yeah, thank you very much for watching this session. I hope it was helpful for all of you. Okay, so subscribe. I will once again say subscribe to the channel and remain updated with everything. Thank you. Bye bye.